Hello everyone, in this lesson we will discuss topics such as what is Packet Tracer, what is it for, how we download it, how we use it. First of all, let me tell you what Packet Tracer is and what it does. Packet Tracer is a network simulation program, a program developed by Cisco to help students learn faster. Because real devices aren't accessible to everyone, it's a program Cisco developed to enable students to work in a lab environment as if they were working on real devices. We can download this program from Cisco's Network Academy site. It is written as Netacad. It is the short spelling of Network Academia. When you come to this site, you must first become a member. You log in after becoming a member. Since I have a previous membership, I am logging in. You make your membership and then you log in. Here under the Resource tab we have the Download Packet Tracer. We will download it from here by clicking here. You can choose which one to download here based on your operating system. There is a 64-bit or 32-bit option if you are using Windows. You can choose and download whichever one you are using. Since I use Mac, I downloaded and installed the Mac version, and you can download and install it here in the same way. After the installation, I will explain it briefly and simply. You will have already seen the details when we make the labs in the following lessons. For now, I'm going to talk mainly about its outlines and features. I open the program. After installing it you need to log in at the first stage. The program does not open without logging in. If you cannot log in, you can also use it in guest mode. The main category here is network devices, end devices, component and cable connections. Here when you click on this sign it shows the cable connections. This is the symbol of automatic cable connection. This is console cable. This is flat cable. This crossover cable. These also represent serial cables. I have already explained which calos we will connect the devices to each other with in the Ethernet cabling class before, so I am not telling you again. We will make an example in a moment. Here we have routers. We have routers such as 4331 series, 4321 series, 1941 series, 2901 series, 2911 series. When we click on our switches here, we have the 2960 series layer 2 switch, we have the 3560 series layer 3 switch, we have the 3650 layer 3 series switches. Within the scope of this training, we will only use routers, switches, servers and PCs, and we will not use other devices in this training. Now let's come back to network devices and take one 2911 series router as an example and put it here. Let's add a switch. It comes here when you hold it like that and pull it off. Let me take this up a little bit. Now let's add a computer. Let's add a laptop. When you click on the connection tab here, it shows the cable options. You click on the PC once to connect it to the switch, and then you come to the computer and select the fast Ethernet interface card from there. After selecting the interface card, when you click on the switch once, it shows the ports here. You choose which port you want to connect to. I'm going to connect someone to their port, and I click on the laptop once in the same way. After selecting the cable, I click on the laptop and select fast Ethernet 0. Then I connect that to the second port of the switch. Now let's select the cable again. When connecting the switches to the router we use straight cable. Let's connect it to the gigabit 0/1 port as well. Let's connect it to the gigabit 00 port on its router. Now that the computers are connected to the switch, spanning tree comes into play, and we'll cover this in our next lessons. Now it's been active, but orange still hasn't been active. The router's interfaces are also turned off in default. We need to turn them on. Here you can see which interface we are using. Here we are using fast Ethernet 0/0. Here we are using fast Ethernet 0/1. Likewise, the laptop's fast Ethernet 0 interface card is connected to the switch's second port. Here it also shows the name of the switch. Here it shows the name of the computer. Here it shows the name of the router. Now let's click on the router. Once you click on the router, the setting page appears. This is the front of the router. I have one of the same router on my desk. We can use this router as if Packet Tracer were real. Here the device has an on-off switch. When you press this button, the device turns off, where the device is turned off when the light goes out. Let me turn the device back on. Right now the device is turned on. This is the front of our device, and this is the back side. On the back of the device, you can see the interfaces and other ports on it. Here the device has USB ports. Here too there is a console connection. Here you can connect via USB console cable. Here you can connect with a normal RJ45 console cable. Let's put a computer here and imagine that this computer is your admin PC. Let's connect this PC to the router with the console cable. Let's select the console cable and click on the PC and select RS-232 and come to the router, or I connect it to the console port as well. At the moment we have made our console connection from the computer to the router. After making the connection, you can access the CLI interface using terminal programs such as PuTTY or Secure CRT. In our next lesson, we will deal with the subject of CLI, and in that lesson I will tell you in a little more detail. Now let's click on our computer. From here, when you come to the desktop and select Terminal and say Connect, you are connected to the router. Here I write No. We will make the settings manually ourselves later. I write No and we are logged into our device. This is how you can connect to the router from your computer via a console cable, but we don't need it in our packet tracer because we can connect directly. I turn off the PC and here I come to the home page. From here I click on the select mark and select it. When I press the symbol here, I wipe the device I have chosen. Since we use packet tracer, we can access the router console directly. This feature is a convenience that the packet tracer program provides us. You cannot do it on the real device. On real devices you have to connect your computer to your router with a console cable. As you can see here, the connection of the router is now red, because the interfaces of this device are also closed by default. Now let's open this interface. Here you can see that its status is up. Now let's take a look here. As you can see, this place has also become green, and when we press here, it speeds up the transactions. As you can see, it immediately turned green on the switch side and all of them are active. I've enlarged these articles and devices a little so that you can see the images here more easily, and let me show you how I do them. If you select Show Device Model Labels from here, you can see the models of your device. This is also open by default. I have removed it. From here you can choose whether to show the name of the device or not. I asked him to show it. From here you can turn the lights on or off of the ports. If you do this you will not see the status of the ports here. You can select these features from here. Here you can choose the font settings. I made 18 to make the articles bigger. The default was 11 or 12. You can select the font from here. Here you can also adjust the size of the device icons. For example, let's make this 11 and apply it. I enlarge the icons here so that you can see them more easily. Now I take them back to 14. You adjust them to your own. In short, these are the features that we use frequently in Packet Tracer. From here you can change it as you want and customize it to your own. In our next lesson on command line interface, I will talk about how to connect to switches, cable types, console cable and serial cable, all of them. In this lesson we briefly talked about Packet Tracer. I will show you in more detail when we already do labs. Here, for example, there is the simulation feature. Let's say we put a ping from here to here and we will switch to the simulation side to see if this ping is gone. And here we will see if the packets are gone. There are many more features like this, and I'll show you all of them. Goodbye to see you in our next lesson. Hello everyone, I will explain the use of command line interface in this lesson. We can use CLI with 3 different methods. Our first method is to connect a direct console cable to access our routers and switches, and our other options are Telnet and SSH, that is, we can access over the network. In order to do this, we first need to connect to our router or switch with our console cable and make Telnet and SSH settings. Once we have set up Telnet and SSH, we can access directly over the network without connecting a console cable. After making the banLAN, there are modes of iOS. Our first mode is Enable mode. This mode is also called Privileged Exec. We have User mode and we have a Global Config mode. I will talk about these modes. Now let's talk about iOS first. iOS, it is the operating system of our Cisco routers and switches. That is, if operating systems such as Windows or Linux provide us with the necessary software for the operation of our computer, the operating system that makes our routers and switches work is iOS. So to be able to configure this iOS, we need to access the CLI, that is, the command line interface. We have 3 different options to access the interface of iOS. Let's take a look at the figure here. In this way we see a 2960 series switch, where we can access the CLI interface by connecting a console cable to our computer and connecting the cable to the console port of the switch. In our other alternatives are Telnet and SSH. As you can see here, we can access our switch over the network using Telnet and SSH. We can connect the console cable to the switch in different ways. The switch has an RJ45 port or a USB port on it. I will show you these on our next page. We can connect with these ports. Let me show you an example console cable. This cable is our rollover cable console cable that we use in Cisco devices, and its color is turquoise. One end has the RJ45 and the other end has the serial connector. Today's laptops do not have a serial connection port. We need to use USB converter because there is no serial connection port. Another type of cable we have is micro USB, so let's take a look at this as well. We connect this cable directly to our laptop from the USB port, not from the serial port, and we connect the micro USB end to our switch. This also is software. You have to download it and install it on your computer. You can find and download this software from Cisco's site, or you can find it from anywhere on the internet. When you install it, you don't need USB converter directly by plugging the USB into your computer, and you can use it with micro USB. But now we have the cable with the RJ45 input, and we connect with this cable because we don't have it on these new devices that are coming out on the old devices, because all of Cisco's devices have an RJ45 console port, so we usually use this cable. This cable also has the ones inside the USB converter. You can see it here. I use this cable. If you want it, you can ask AliExpress. In the part you see here, they put the USB serial converter in here. You plug the USB end directly into your computer. You can take it to the other end and connect it to the RJ45 console port of the switch or router and use it. Here we plug the cable into the serial port of our computer, RJ45 at the other end. We connect this end to the switch and we get access to the CLI. And this is the USB converter connection I showed you. Again, we use our normal rollover cable. This is serial. This is RJ45. Here we have a USB serial converter cable. With this converter, we can connect it directly to the USB port of our computer. The third option is that we connect it to the micro USB port of our switch and to the USB port of our computer, and that is why we also have a software that we download this software and install it on our computer, and that is how we connect. I put an example here as an example of a 2960XR switch, and let me show you over it. This is our classic RJ45 console connection, and this is our micro USB connection. You can connect via the cable I showed. In order for us to access the console interface, the CLI, we need to use a terminal program. For example, there is a program we call PuTTY. You can use it. I have a program called Secure CRT. I use it. I can use it as you want. Now I'm going to show you how you can connect via Secure CRT. Now we have made our physical connection and we will access the CLI. In order to access the CLI, we need a terminal program. This program can be programs such as PuTTY or Secure CRT. Now let me show you how to connect with Secure CRT. I immediately select the new connection from here. From here he asks me, will you connect via SSH or Telnet? I will connect with serial, so I will connect physically. Even if you use USB converter, you need to select serial. It asks which port on your computer we connect our cable to, where you choose your port number. You can find out this port number by looking in the device manager in Windows. Here the default baud rate value is 9600. We select 9600. Data bits 8, stop bit to 1, parity none. Here we give the link a name. You can give it a name you want. When you say OK, the process is finished. I say cancel because I have already set it up. I will use it. Now let me try to connect. It turns out this way because I don't have any cable connection at the moment. Now I'm going to show you how you can also connect in Packet Tracer. Now let me show you on Packet Tracer. Let's come to Network Devices from here. Let's choose a switch from here. Let's take one switch and put it here. Let's connect a computer immediately. Let's come to the End Devices from here. Let's get a PC here and put it here. First of all, let me show you how to connect to our switch with our console cable via PC as if we were connecting with a real device. Let's come to the type of cable from here, select the console cable and connect it to the serial port of our computer. From here, let's come to our switch and connect with the console cable. Let's pretend we're connecting with real devices. Let's come to the terminal in the desktop section from here, where the place we call the terminal actually replaces PuTTY or Secure CRT. Packet Tracer provides us with this convenience in the virtual environment, but in the real environment you open the PuTTY or Secure CRT program on your computer. When you open your terminal program, you enter the default connection settings here, say OK, and access your switch. After accessing the switch we have different levels of modes here. The first mode we log in is the user mode. The first time you access here with the console cable or Telnet you log into the user mode level. In user mode, enable mode and global config mode, we can make different configurations, so Cisco has separated these modes. The operations we can do in user mode are different. In enable mode, i.e. privileged exec mode, we can do different operations, and in global mode we can do different operations. In each mode we can do different operations. If you see a large sign here, you are in user mode. This is the first mode we log in. You plug in the console cable and access user mode. You need a password to access here, but now we can access user mode without password when we connect our cable directly because it is in the default settings. When we give a password to the console port, you will first enter the password and then access the user mode, but there is no password at the moment. To switch to enable mode, you type enable and press enter. When you press enter you are now in enable mode. where if you see the D is sign, this mode is enable mode. Let's put a question mark. When we put a question mark, it shows all the commands that we can use in this mode. Now let's come back again. When we write disable here, it switches back to user mode. Now let's put a question mark here again and press enter. As you can see here, the commands that we can use in user mode are different. There are commands such as connect, disable, disconnect, enable, show, telnet, terminal, and traceroute. Let's go back to enable mode. Let's make a question mark here. As you can see, the commands we can use here are different and each mode has its own specific commands. Now let's move to the global config mode. When you type CONF and press tab, it completes the command you typed. Now I type T, press tab, and it completes the command. There should be no other command that starts with T to complete the command. If there is another command that starts with T, when you press tab it does not complete the command. Now let's exit. For example, when we type TR here and press the question mark, it shows the commands that start with TR. When you type T and press the question mark, it shows all the commands that start with T, where there are 3 commands that start with T. Now I type T and press tab, but it doesn't complete the command. But when I type TR it completes the command, because there is no other command that starts with TR, so when I type TR and press tab, it completes the command. For example, now I type T and press tab, but it does not complete the command because there is telnet and terminal command that starts with T. If I type TR and press tab, it completes the terminal command. This feature is an ease of the iOS operating system. For now our modes are briefly like this. In order to connect with telnet and SSH, we first need to make a physical connection. After making our physical connection, we will first set up telnet and then we will be able to access it with telnet. Now let's talk a little bit about the difference between telnet and SSH. Telnet sends clear text, that is, commands openly, but when we use SSH, even if there is someone listening to our network, they cannot see the data because it is encrypted, so we should generally prefer SSH. We have already talked about modes. Our user mode, we move from user mode to enable mode. We switch from enable mode to configure terminal mode. We can come to enable mode by doing Ctrl+Z again. We use the disable command to exit enable mode. Here we have sample commands for iOS configuration: enable, enable to exit disable. Configure terminal command is the command we switch to global mode. We use the hostname command to name our device. We give a password to our physical console entry here with the line console housing. If you do not set this, you can log in when you bring the console cable directly here and plug it in, but you need to give a password to this port to prevent unauthorized people from connecting. We also use the line console 0 command and the login command to give a password to this port. When you do this, someone can no longer bring the cable and plug it into our console port and log in. Only the one who knows the password will log in. Now let me show you these commands in Packet Tracer. Let's add a switch to our workspace in Packet Tracer. Below we choose the switch for network devices. Let's put one of our 2960 series switches here. After putting the switch here, when we click on it once, the physical appearance of our device comes. From here we can access the console directly by clicking on the CLI. Here we are in user mode. We use the enable command so that we can switch from user mode to enable mode. When I type EN and press tab, it completes the command because there is no other command that starts with EN, but when I type E and press tab, it does not complete. When I type EN and press tab, it completes because there are no other commands that start with EN. Enable mode is also referred to as privileged exec mode. This question comes up in the CCNA exam. Let this sign know which mode you see, which sign shows this sign, and which mode this sign asks. Now let me show you the exit from enable mode. When I emit dis and press tab, it does not complete. Let's put a question mark. As you can see, there is disable and disconnect. Both commands do not complete when I press tab because they start with dis. When I type dis and press tab, it completes. Now we have switched to user mode again. I switch to enable mode again. There is also something like this. When you type EN and press enter, it goes directly into enable mode. Because there is no other command that starts with N, you do not need to press tab. You do not need to press N directly, and when you press enter, it enters. For example, I type con and press tab, but it doesn't come out. When I type CONF and press, it comes out. I write T and press tab again and it completes the command. When we enter, we are now in global config mode. In this mode we can make all the highest level settings related to our device. You can use Ctrl+Z to get out of here. Now we have switched to enable mode again. I write CONFT briefly again, because when we type CONFT it is directly changed to global config mode because it provides a match with the configure terminal. From here we can come to the top when we type end. Let's write CONFT again, short for configure terminal. Now let's change the hostname of our device you see here. I write the hostname, you can also write it short. I recommend using the tab key because it allows you to write the commands correctly, so I wrote host, I pressed tab. Let the hostname be cloud SW. When I pressed enter, the hostname of our device changed. This command sets the name of our device. Now let's give a password to the line console entry, write the line and press the tab and complete it, press the question mark and see what happens. As you can see here there is line console and line VTY. The line console command is the command we use to give a password to our console port, and line VTY is the command we use for telnet and SSH. Since we are going to set up the console now, we write console 0 in the line, write pass and press tab and it has completed as password, get console in our password. We also call it login. Now I come to the top by writing end here. From here I exit with disable. We will restart our device. It asks if the settings you have made should be saved. Let's save it by saying yes. Right now our device restarts. In the meantime you have seen the reload command. Here you can see the iOS version of our device. This is the iOS version of our device. What we call flash is the memory of our switch, and the iOS software is installed here. Here we show the version 12.2. Here it shows the model of our device. Here you can also see the serial number. Now, when you first log in, user mode asks for password. We have set our password as console. Here it does not show the password when typing, it is entered secretly. Now let's move on to enable mode. When we enter the enable mode it does not ask for any password. This mode allows me to give the password. Let's switch to global config mode to set the enable mode password. After typing configure terminal, we write enable password, let our password be Cisco. Let's do Ctrl+Z, let's do disable. Now we are in user mode. Now we will switch to enable mode again. As you can see, now we ask for a password to go to enable mode. We have made our password Cisco. When we type our password, we can now switch to enable mode. We can check the settings we make here with the show command. Let's write show and press the question mark. This command is a command that we use to show the configurations on our device. We will use the running config command here. All the settings we currently make on our device are saved in the configuration file we call running config. There is also a startup config file, which is the file that stores the permanent configurations of our device. The commands we entered are currently working in running config. If we do not print them on the startup config file, when we restart our device starts with the previously configured configurations in the startup config. That is, all the configurations we have made so far are deleted, so we need to print all the configurations we have made on the startup config. First let's look at a show running config, then these configurations are permanent. Let's print it to the startup config file. When I type show run and press tab, the command completes. Here you can see with this command how much configuration we have made on our device. The short software of this is show run. When you type show run and press enter, it shows all the settings on your device. For example, you can see the enable password here, we just set it up. Below are our line console. Here you can see the line console and password configurations. We have not memorized these settings. If we restart our device, the settings will go on this device. We need to print the configuration on startup config with the copy running config command so that these settings do not go. When our device is first turned on, it opens with the settings here. If we do not save the changes we have made, the changes we have made will go, so you have to do this after each change you make. There's also a short command to this, which saves it the same way when we type write, but you can only use this command in enable mode. In configure mode this command does not work. This mode does not work with the copy command. I'm coming back to enable mode by saying exit. We accessed our switch using CLI and made a few simple command inputs. We will talk about the configurations of the switches in our next lessons. Goodbye to see you in our next lesson. Hello everyone, in this lesson we will give an overview of the switches. First we will make a LAN switching concept, then we will give an overview of the working logic of the switches. We will finish our lesson by looking at the commands for learning MAC addresses, avoiding looping and finally analyzing and validating the switches. First, let's take a look at the LAN switching concept. As you can see here, we have one yellow network, we have a blue network. The blue side has the data center local area network, and on the yellow side we have the campus local area network. Here are a few important issues that we must pay attention to when designing our networks, one of which is how much traffic will be and what kind of devices will we connect to our switches. We will choose their models and capacities according to the type and traffic of the devices that we will connect to our switch. Here on the blue side there are servers, and on the yellow side there are end-user devices, as you can see. Here we call the switches that the end users connect to access switches, in the same way that the switches that the servers connect to here on the data center side are also called access switches, and the switches to which we connect access switches are called distribution switches. Terms such as distribution switch, access switch, and core switch will be addressed one by one when designing the network in the network architecture section. When we design our network, we need to pay attention to how much traffic will be in our network and what kind of devices will be connected to our switch. The working logic of switches is based on MAC addresses. Switches use MAC addresses when transmitting packets from one port to one port. They also report their MAC address to the switch when users connect to the switch's port and generate a traffic, that is, when they send an Ethernet frame. As you can see here on the switch, it adds the MAC address table to the MAC table according to which port that user is on. Now here's an example of sending a frame. Let's examine it. Fred, it sends packets to Barney. First comes the frame from Fast Ethernet 0/1. The switch adds the source MAC address of the incoming client to the MAC table. The MAC address of the user coming from Fast Ethernet 0/1 is 11. Fred user will go to Barney. Barney's MAC address is 22, and Fast Ethernet is using 0/2. The switch sends the incoming packet directly to Fast Ethernet 0/2. It does not send this packet to other ports, so it also filters here, both forwarding and filtering. The incoming package is forwarded to the relevant destination port, but not to other ports, and the working logic of the switch is briefly like this. Now let's look at a little more details on this page. Layer 2 has three main functions. We have mentioned them. The first function is to learn MAC addresses, and the second active feature is to make forward and filter decisions. In the example here, frame Fast Ethernet comes from 0/1 and will go to Wilma, but here they misspelled the MAC address when typing it into the figure. This will be 33, ignore what says here. Fast Ethernet checks the destination MAC address when the frame arrives from 0/1 and finds that it is in gigabit 0/1. This MAC has learned the address from the switch 2 and sends the incoming packet to the switch 2. Now let's look at the second switch. The second switch takes the packet from switch 1 and compares the MAC address in this packet with the MAC address table, and determines that Wilma's MAC address is in Fast Ethernet 0/3 and forwards the packet to this port, so that it sends the packet from Fred to switch 1 switch 2, and switch 2 looks at the MAC table and forwards it to Fast Ethernet 0/3. Our learning of the MAC address here starts with Fred sending a frame packet to switch 1, then the switch makes its forward and filter decisions and decides where to send it. That is, it looks at the MAC table and forwards it and does not transmit any packets to the other ports, or it filters the others. After that, it comes back to the second switch and looks at the MAC address of it on the second switch and transmits it to the end user. In the first step, the MAC table is empty on the switch. When an Ethernet frame is sent, the switch adds the MAC addresses to the MAC table. As you can see here, when Fred Barney is going to forward a packet, he sends a frame packet to the switch, adding his MAC address to the MAC address table as Fast Ethernet 0/1. Let's look at the second frame. Fred sent his packet to Barney, and now Barney will return to this packet, and when Barney returns, he sends a frame packet, and when Barney sends a frame packet, the switch adds his MAC address to the MAC address table, so the switch learns the MAC address of both users, after which it will go between these two users and provide the future traffic through these ports. Now let's look at avoiding loop on the right side of our page. What is loop avoidance? As you can see here, we have a switch, here we have a switch, here we have a switch. Let's imagine that we connect these switches together in a circle. When you make a connection like this, Larry is going to send a frame, and he sends it from this switch to this switch, he comes back from this switch back to this switch, he comes back here and here, and it causes a vicious circle in the network. To prevent this vicious cycle, we can prevent this cycle by using the spanning tree protocol on switches. When it comes to spanning tree, I'm going to talk about this protocol. Let's look at the commands we use to analyze and verify switches on this page, but before we look at these commands, let's take a look at the default settings of our switch. In default, interfaces are enabled on switches. After connecting the cable starts working, all we have to do is plug in the switch and bring and connect the end user devices to the ports. These ports also work in 10/100 megabits or 10/100/1000 megabits. These vary depending on the model of the switch. If the interface card of our end user device is 100 megabytes, when we plug it into the switch automatically sets that port to 100 megabits per second. If the end user's computer or whatever device we are plugging in, the interface card of that device supports 1 gigabit per second, that switch sets that port to 1 gigabyte. Apart from that, MAC address learning, routing, filtering logic on switches also works by default. The spanning tree protocol we use to avoid looping is also enabled by default. Now let's look at the show commands. We use the show commands in enable mode. If you remember when using CLI, we explained these modes. There was user mode, enable and config mode. Packet Tracer does not support all the commands I have written here. For example, it supports this command as well, but it does not support it. It only supports 1 or 2 commands here. It does not support all of them. You can try other commands when you use real devices. When we type show MAC address table dynamic, you can see the MAC addresses that the switch learns dynamically. The show interface status command also shows the status of the interface. With this command, you can also see outgoing packets from fast Ethernet 0/1. In this command, you can dynamically see which interface this MAC address is in. Here, on the contrary, you find out the MAC address of the connected device in fast Ethernet 0/1. In this command, you learn the MAC address of the devices in VLAN1. Here you can see how many records are in the switch MAC table and how much more records it can keep. This may vary depending on the model of the device. When the switch's MAC address table is full, the switch can no longer respond to newly arrived packets, which is a vulnerability for malicious use, and we can prevent this with port security commands. That's all we'll tell you in this lesson for now, so goodbye to see you in our next lesson. Hello everyone, I will tell you about the basic switch configurations in this lesson. First, I will talk about CLI security on our switch, then I will tell you how to secure the passwords we give for console, telnet and SSH to access user mode. Then I'm going to talk about local usernames, how do we use local usernames in AAA, and in our next lesson we'll talk about SSH configuration and IP switches to them. Now let's look at CLI security first. If you remember, we had user mode, enable mode and global config modes, and we had to give passwords to access these modes. In order to access the user mode, we give a password to the console port of our switch or router in this way. If you remember, we logged into global mode and gave our password for console login using the commands here. After giving the password, console asks us this password when we plug our console cable into the console port of our device and try to access user mode. In the same way we give the password for line VTY, this is VTY, it is the virtual terminal port that we use for telnet and SSH. We configure telnet and SSH settings to be able to access our devices from anywhere over the network. We do not have to use a console cable at all times and be near the device. We use the virtual terminal port to be able to access the device remotely. We set these ports with the line VTY 0 to 15 command, and we use the login command and password command for line VTY. Once we have given the password, we can access the CLI by opening a terminal program through the network. After accessing user mode, we need to switch to enable mode, and we need to give an enable password to go to enable mode. If you are connecting from line VTY, telnet and SSH, you must have an enable password. You enter user mode without an enable password, but if you are not given an enable password, you cannot proceed further. I've written the commands that we're going to enter here. We'll do them a little later. First we come to global mode by typing configure terminal, then we give our enable password, line console 0, we write our password and exit by logging in, then line VTY 015, 0 to 15 here determines how many people to connect. If we make this place 0 to 15, 16 people can connect at the same time. We give our password and say login. Here is a configuration output that has already been done, where our password appears as secret because we use the enable secret command. When we type show running config in the command line, it shows all the configuration that is running on our device. When we look here, our passwords appear to be open, and when someone next to us looks at this, they can see our passwords. We also need to hide these passwords, so we create usernames in the local database of our router and switch, and now we use the login local command instead of login. When we use the login local command, it checks the database for the users who will be logged in and allows us to log in with this username and password. Then our password does not appear here. Let's make an application of it. Let's open Packet Tracer, and from here we come to the switches from our network devices and select the 2960 model and put it here. Let's click on it once. When we zoom in from here you can see the physical appearance of the device. This device is a switch with 24 ports and 2 uplink ports. Let's come to the CLI right here. At the moment, our switch is turned on. Let's say enter. As you can see right now, we are in user mode. Let's write enable immediately. In enable and user mode, we can log in directly because there is currently no password. Let's write configure terminal. Let's create a password for privileged exec mode after switching to global mode. Let's write enable and put a question mark. You can type password or secret here. When you type password, the passwords do not appear as secret in show run, so use the secret command here. Let's write secret and set our password. After giving our enable password, let's also give our line console password. I write line console 0, we write 0 because we have only one port. Let's write login first. When we type login, it asks us to write the password first, and our password is Cisco 123 again. Now we can write login. Now let's exit and set up telnet. I type line and put a question mark. After line we can use the console and VTY commands. Let's select VTY here and put a question mark again. Here we can enter a value between 0 and 15, let's write 0 to 15. Let's write password here, let's say telnet, let's say login. When we type end here, we go directly to enable mode. Now let's check the configurations we have made with the show running config command. We did not save the settings we made now. If you turn off and turn on the device without saving what you do, your settings will go. So we need to dial these settings into the startup config file. Let's write copy running first. When I press tab, it completes. We will copy it onto the startup config. If you remember, there was a short way to do this, and our short command is write, which works the same when we write. These commands run in enable mode. Let's check the settings we made by saying show run. As you can see, our password is encrypted with MD5 here. It shows that there are 5 MD5 here. Now let's go down. As you can see here, our line console password seems to be open. When you look here, the password of the telnet also seems to be open. Someone standing next to us can see these passwords, so we need to remove these passwords and use the users in the database. I write CONFT, this is the abbreviation of configure terminal. Now let's create a user, username Yavuz. We are now creating a user in the local database. Our password is also secret and gets Cisco 123. Let's enter. We have one user in our local database now. Now we can use this user for user mode access, but we need to make changes under line console and line VTY. Let's say line console 0. Now we just need to write login local. We say use the users in the local database when logging in. Now let's do the same in line VTY. With your computer's arrow keys, you can see the commands you entered earlier. When I find the line VTY 015 command, I press enter, I find the login local command again. In this case, I write login local and I exit. Let's exit again, or we can return to enable mode by writing end. Now let's write a show run again. Here you can see the user we created. We cannot see our password here because we made it secret. Here we entered the login local command, but our old password appears here. Now we can remove this password. When I press Q, I directly end the process, configure terminal and line console 0. If you want to remove a command, you type no at the beginning of that command, and if you type no and type the same command again, you remove that command. For example, let's copy and paste this into the command line. Now we have removed our old password. We don't need that password anymore, because we will be able to log in with the username in the database. Let's do the line VTY in the same way. Let's say exit. Line VTY 015 after writing no password. The password for this was telnet. Let's write it down. I say end and switch to enable mode. Here I say show run. As you can see here, our user password is secret. Now let's look below. Our passwords no longer appear here. We have secured our passwords. Now let's log out of our device, save our settings first, then write disable. When we type disable, we came back to user mode. Let's go back to enable mode. As you can see, it now asks for a password when switching to enable mode. When we restart our device, it will ask for the password for user mode. This username and password are now stored in the local database and our password does not appear in show run. As you can see, it now asks us to enter the username here. When we give a password directly under the line console without using a username, it does not ask for a username here, it only asks for a password, but since we use the login local command, it now asks for the username and password together. Now we will switch to enable mode, and to switch to enable mode, our password is Cisco 123. Let's do a show run again and check our settings. As you can see, here we have our username and password. We have stored our usernames and passwords in the local database of our device, but if we want, we can store these usernames and passwords on a remote server by making AAA configuration. The meaning of these three A's is authentication, accounting, authorization. By doing this configuration we can make our usernames and passwords more secure. In large companies, this is usually used. We can use servers that use Radius or TSACS protocols. The TSACS protocol is specific to Cisco. Cisco has a product called IS Identity Service Engine. This device is a device that supports TSACS and Radius protocols. On this page, let's take a brief look at authentication servers. For example, we want to access our switch from this user. We have just created a username and password in the local database. We create the username and password on our device again. But first we can also choose the username and password verification method from a remote server. For example, when the user accesses the device, we can first verify the identity and password information on the remote server and then access the device. Let's say he could not access the remote server, then as a second option we can allow him to log in using his username and password in the local database. This is entirely up to you, or you can say that AAA should not access the device when it cannot access the server. Here's a look at how authentication with the AAA server works. When the user tries to access the device they want to log into, that device goes to the AAA server to confirm that user's username and password. If the user authenticates to the AAA server, it allows them to connect via Telnet or SSH, and that's how the external authentication process works. That's all we have to say in this lesson for now, so be honest to see you in our next lesson. Hello everyone, in this lesson I will show you how to configure SSH. Let's come to the network devices and choose one switch. Let's put one 2960 series switch here. After that, let's put a computer. Let's connect them with a straight cable. I select Fast Ethernet 0/1 and connect it to the first port of the switch. Now let's connect a console cable. This time, let's access the CLI from the computer, not directly from the switch. I immediately chose the console cable as well. I also connected the console cable here. I open it by clicking on the computer once. From here I come to desktop. When we click on the terminal, we have default settings here. OK, and let's connect. Now that we are logged into the device, let's switch to enable mode and write CONFT. Here, first of all, let's give the enable password. Our command is enable secret, our password is Cisco 123. Then let's set our username, so the username is Yavuz. I write secret Cisco 123, I have created a username in the local database. We need to change the default name of the switch for the SSH connection. I write hostname switch 1. Once we have set this we need to write a domain name. Our command is IP domain name booleut.com. Then the command we need to enter is crypto key generate. I press tab and complete. When you press the question mark, I show the command you can enter. Type RSA and press enter. Here he asks how many bits the encryption will be. I do 1024. He has now created our key, and after creating this key, we select it as IP SSH version 2. After making the SSH settings, let's adjust the line console and line VTY settings. If we make the line VTY settings, we can access it from Telnet and SSH. If we enter the line console password, we give the password for the physical console connection. Let's set up the line console first. Let's say line console 0 login local and log out of here. Now let's make line VTY virtual terminal settings. Let's write line VTY 015. Let's write login local. Let's type exit and save our settings. Now let's check the settings we made by making a show run. As you can see here we have the hostname, here we have the enable secret password, your SSH version is 2, the domain name booleut.com, here we have the username. Since we have entered the login local command under the line console here, we can now log in with a password. Right now, we are directly connected to our device with the console cable. We have not yet connected over the network. Now let's exit and re-enter. I write the username and password. Let's write enable. The password here is Cisco 123. Now we have a physical connection to our device, but we no longer want to access this device with the console cable, but with SSH. To access it via SSH or Telnet, we need to give an IP address to our switch and computer. First of all, let's configure the IP of our switch. We cannot give IP to the ports on the switches, we can give IP to the ports because the routers are layer 3 devices, but in the switches we give IP to the VLANs, and since the default is VLAN1, we will give an IP to VLAN1. Let's enter the global config mode. When I type int and press tab, it completes the interface, because there are no other commands that start with int. I type interface VLAN1 and say enter. When I type IP add and press tab, it completes. Our address is 192.168.10.1. Subnet mask 255.255.255.0. There is also a no shutdown command, which opens interface. If there are different VLANs in our network, for example if we try to access this switch from the 192.168.20.0 network or the 192.168.30.0 network, this switch must have a default gateway, so we must enter the default gateway IP. The same subnet does not need this, but if you want to access this subnet from a different subnet, remember to set the default gateway IP address in the switch. If you want, you can enter the command without exiting here, but for now I am logging out so that you do not get confused. Our command IP default gateway 192.168.10.254. You don't need to type subnet mask here because you're in the same subnet. Let's exit and save our settings. Now let's check our settings with the show run command. As you can see here, we have enable password, SSH settings, and username. When we come to the bottom, you can see our IP address and default gateway IP address here. Now let's get out of here and set the IP address of our computer by coming to IP configuration. Let our IP address be 192.168.10.2. When you click here, the default is the subnet mask. Now let's get out of here. Let's check if we have access to the switch by pinging by opening the command line here. I write ping 192.168.10.1, we gave this IP address to the switch. At first it hit a timeout, but then our connection came, so let's try again. As you can see now, we have access to our device. Now let's log out of here as well. You need to open the PuTTY or secure CRT program on your computer and connect from Telnet or SSH. Now that this is a virtual environment, this computer has software for Telnet and SSH on it. Let's try a Telnet first, then we try SSH. The IP of our switch is 192.168.10.1. We say connect. As you can see it is opened immediately. Here we will enter our username and password. Switching to enable mode, the password is Cisco 123. Let's check the settings by typing show run. As you can see we were able to access the switch. Now I press Q and we end our connection by saying exit. Now let's get out of here and try SSH. Here we write our IP address, with SSH selected, 192.168.10.1. We write our username, we say connect, and we write our password. Let's go to enable mode and type in our password. As you can see, we have also provided our connection with SSH. Now let's go back to our topology. Now here we can access our device over the network without our console cable. If you want, let's remove our console cable. As you can see, now our computer can connect to the switch via the network via SSH or Telnet. You can also configure SSH this way. Goodbye to see you in our next lesson. Hello everyone, I will tell you about how to configure switch interfaces in this lesson. There are some commands that we can enter under our interfaces. I will talk about them. Determining our speed. We have commands such as half duplex or full duplex to work. I will show them to you. How to observe the status of these interfaces, and we will finish our lesson by looking at the topic of auto negotiation on the switches. First of all, there are some features that we can use in the ports of our switch. Let's look at them. I have written the commands we will use here. You can look at it later from your fabric. Now let's open our packet tracer and execute the commands I have written here. Let's come to the network devices here. Let's add a switch. Let's add one PC to the end devices. Let's add one more PC. Let's connect them with automatic cable. When you click on the computer and the switch, it automatically selects a port and cable type according to the device. Let's connect it right away. This way we connect it quickly. Let's immediately enter our switch and turn on CLI. I write enable and then I enter configure terminal mode. I write interface fast Ethernet. This switch of ours supports 10 megabit and 100 megabyte speeds, so I have fast Ethernet. There is no gigabyte Ethernet. I log into port 0/1. Here I will choose whether our port will work half duplex or full duplex. Already this default is also in automatic mode. You do not need to do anything, but if you need to do it manually or change it, you can change it with this command. We have half, full and auto options. The default is also automatic mode. Let's do it fully. Let's make our speed 10 megabits. Let's write a statement. It depends on the printer on the port. What good is it for you to write these descriptions? If you specify which devices are connected to these ports with explanations, you can see which devices are connected to these ports when you connect to this device and look at the show running output. For example, access point is connected, IP camera is connected, or you can write that access point is connected on the second floor, or you can access remotely and see which device is connected on that port when you need to close and open that port, which is a nice feature for him. Let's call it show run. As you can see, the speed of our interface is 10 megabits, it will work as a full duplex and we wrote in the description. But let's say we want to set up ports 2 to 5 at the same time, so what do we need to do? I immediately pressed Q, I enter the global command mode. I write interface range fast Ethernet and say 0/2-5, so we'll make the same settings from the second port to the fifth port. Let it be speed 100, full duplex. Let's write the end user in the description. Let's call it end and check our settings with show run. As you can see here, we have set up 4 ports in bulk. With this range command you can make bulk configuration in this way. Now let's check our interfaces. When we type show interface status, it shows the status of our interfaces. As you can see here, all the interfaces are set to full. You can see that we have also made the first port 10 megabits, the others are currently in automatic mode. Let's look at our other commands. Show interface fast Ethernet 0/1. This command gives details about our port. Here you can see that the port is closed. Here it shows the MAC address. Here it also has its description. Here you can also see that it works in full duplex and is 10 megabits. Let's look at auto negotiation on this page. Auto negotiation is the automatic control mechanism available on our switch. It negotiates with the devices that connect to our switch and automatically determines information such as the mode and speed of this port. Do you support 10 megabytes or 100 megabytes? Half duplex or full duplex negotiates issues such as are you working? Auto negotiation is enabled in default. As you can see here, a 10 megabytes computer is connected to our switch. This computer says my speed is 10 megabits and I can work full duplex. Then on the switch it can set this port to 10 megabits and full. Our other user says that my speed is 100 megabits and I can work full. Then on the switch he sets this port to 100 megabits and works 100 megabytes. If our user here supports 1000 megabytes, the port of our switch works as 1000 megabits. Let's take a look at the example here. The switch side is automatic and the user manually makes 100 megabytes on the user's side. The switch automatically makes itself 100 megabytes. When the device here is 1000 megabytes, the switch automatically becomes 1000 megabits. And when the device here works 10 megabits and half duplex, the switch sets itself as 10 megabytes half duplex. Let's look at our example on the right side. As you can see here, our switch has 1 gigabyte of ports and we have 2 computers. These computers work as 1 gigabit, but since our old hub devices work 10 megabits and half duplex, this switch has a port of 10 megabytes and half duplex works, and therefore on devices above this hub 10 megabits half duplex works. Auto negotiation also works in this way, that is, by negotiating between our devices, it determines the speed of the port of that device, whether it will work half duplex or full duplex. That's it in this lesson. Goodbye, see you in our next lesson.